Yes, ma'am. In this video, I am going to discuss about determinant of a matrix. Determinant of a matrix. First, to define that, let us take first two linear equations. A1x plus b1y equals to c1. A2x plus b2y equals to c2. These two are linear equations in two variables. Okay, got linear equations. So if we have to find the solutions, whether these two linear equations are having a unique solution or not, we have a formula, that is a1 b2 minus a2 b1. a2 b1. This is to find whether the linear equations have unique solution or not. Unique solutions or not. Okay, this is the formula to find whether the linear equation is unique or not. So, before that, we write this in the matrix form, taking all the coefficients in a matrix form. A1, B1, A2, B2. If you observe in this equation, in this formula, what you have? A1 into B2, A2 into B1. Okay, like this we find, and so this is called as we are finding the unique solution or not by this formula. This formula is called as determinant. Okay, so before defining exact definition of a determinant of a matrix, before defining the exact definition of a determinant of matrix, first we must say about minor of matrix. So we know that minor of a matrix is defined as minor of matrix is defined as determinant of 2 by 2 matrix after deleting a row and a column in which the element is present. Let us see one example for that. Example, let us take A equal to A1, B1, C1, A2, B2, C2, A3, B3, C3. Okay, now minor of if you take B2, minor of B2, what you will do is, see, this one and this one must be deleted. Now you have to write in the dashes A1, C1. What remains? My A1, C1, A3, C3. This remains. So what we write here for this determinant means what happens? AD minus BC. AD minus BC. This is A. This is A, B, C, D means AD minus BC. So A1 C3 minus A3 C1. Like this we find the minor. Okay. Next, after minor, After minor, we have one more thing to understand before finding the determinant of a matrix. What is that? Cofactor. Second one is cofactor of an element. Cofactor of an element. Cofactor of an element is nothing but cofactor of an element is nothing but minor of that element multiplied by minus 1 power I plus j. What do you know by I and j, ma? I through jth column. Here I refers to ith row and j refers to jth column. Got it, ma? So for this, in the previous example we got, okay, let us take one more example for this. B equal to, again, A1 B1 C1, A2 B2 C2, A3 B3 C3. If I have to find cofactor of, say for example, cofactor of A2. Okay, if I have to write cofactor of A2, what you will do? A2 equal to cofactor of A2 equal to, I will write here, minus 1 power. Here we know that I is row and j is column. So column number and row number and column number must be added. This is which row, ma? This is this first row, this is second row, this is third row. So row is what? 2 plus, and what is the column? This is first, this is second, this is third. So what is the column? 1. So minus 1 power 2 plus 1. Then in the previous minor, what we have done? A2. Here we are doing for A2. So this and this must be deleted and write the remaining elements. AD minus BC. So B1 C3 minus B3 C1. Okay. Write one more cofactor. Shall we write? Cofactor of, take B3 equals to minus 1 power. B3 is in which row, which column? Third row, second column. So 3 plus 2 and in brackets B3 we are doing. So this and this must be deleted. This and this must be deleted. Remaining A1 C1, A2 C2. That means A1 C2 minus A2 C1. Like this we find the cofactor of a element. Cofactor of an element. Now coming to determinant. Why I said these all before finding the determinant? These all the basic things you must do while finding the determinant of a matrix. Determinant of a matrix. Determinant of a matrix. What is determinant of a matrix? The sum of product of first row, elements of a first row of first row with their corresponding cofactors. Okay, ma. The sum of product of elements of first row with the corresponding cofactors is called determinant. Okay. Before whatever we did, the all means while finding the determinant, we must use those all. Okay. So let us take example. Again, A equals to A1, A2, A3, A4, B1, B2, B3, B4, C1, C2, C3, C4. So what is the order of this matrix, ma? What is the order? How many rows? 3 rows. 3 into how many columns? 1, 2, 3, 4. 3 into 3 by 4 order. Okay, now to find a determinant. How we'll write while finding the determinant? This is square brackets. Instead of square brackets, we must put like this and A1, A2, A3, A4, B1, B2, B3, B4, C1, C2, C3, C4. In this way you have to write. Means det of A. Det of A is denoted in this way. Det of A is denoted in this way. So, let us take one example with numbers, not alphabets, okay? By numbers, if we do means you can easily understand whatever I said till now. You can understand whatever I said till now. Let us take A equal to 1, 0, minus 2, 3, minus 1, 2, 4, 5 and 6. This is the matrix. Now to find that A. So that A is equal to 1, 0, minus 2, 3, minus 1, 2, 4, 5, 6. Okay. So while doing that, what first we will do, ma? What first we will do? Cofactor. We must find the cofactor. Sum of product of elements of first row with their corresponding two cofactors. Okay. So let us do that. That equals 1 into, what is cofactor? Minus 1 power. This is first column, second column, third column, first row, second row, third row. Right? So first row, first column. So 1 plus 1 in brackets. Close this all. What remains? Minus 1, 2, 5, 6 remains. So this into this minus this into this. Minus 1 into 6 minus 2 into 5. Next, coming to second element. My plus 0 into minus 1 power. What is this? The first row and second column. So 1 plus 2 into, if we close this all, what remains? 3 into 6 minus 2 into 4. 3 into 6 minus 2 into 4. Next, here this third minus 2 plus minus 2 into minus 1 power. What ma this? First row, third column. So 1 plus 3 in brackets. Close this all. Close this all. What remains? 3, 5 minus 1, 4. So 3 5s are 3. 3 into 5 minus 4 into minus 1. Next ma. Next, just these all calculate this. Simplify this by using whatever it is there. Minus 1 power, 1 plus 1 means 2. Minus 1 square is 1. So 1 into 1 is 1. So 1 into 6 minus 10. And this is minus 6. Minus 1 into 6 is minus 6. Minus 10. Plus, here what you observe? 0 into. So 0 into anything, what happens? 0 into anything is 0. So 0 plus minus 2 into minus 1 power 1 plus 3 means 4. For even powers of minus 1, you will get positive. For odd powers of -1, you will get negative. Here it is, the power is even. So the what the value you will get for -1, 1. So -2 into 1 into 3 5 are 15. Here this comes -4, minus minus plus. So 15 plus 4, that is 15 plus 4. That equal to -6 minus 10 is nothing but -16. This is plus 0. This is minus into plus, minus 2 into 15 plus 4, 19. That equals 1 into -16, -16. This is -38. That equals, here two negative values, same sign. So as we are having same sign, we must add them and put negative symbol for that. So what you will get, 8 plus 6, 14, 1, 4 plus 1, 5, 54. Means -54 is the determinant for the given matrix. In this way we can find easily the determinant of a matrix. Yes, ma, in this video what we have learned? We have learned how to find the determinant. Before finding the determinant, what we have did? We find minor of the matrix and cofactor of elements.